Right, calculus. So we've skipped over sections 5.2 and 5.3. If you flip through those, you'll see it's an introduction to area beneath a curve, and that is exactly what integration is doing, is finding the area underneath a curve to prove either total distance traveled or distance from a starting point. There's many different applications we can look at. I encourage you to look at 5.3 as different ways to set up area under a curve. Now we're going to be doing it fundamentally using calculus in algebra. So this, folks, is a definite integral. And that is what you're going to be working on the next 2 days, is evaluating definite integrals. So this is going to use all of your rules that you've used for your indefinite integrals in section 5.1. But we're now going to add in the fact that we have our bounds in which we're going to find the area under the curve of f of x dx from point A to point B. So what will this look like? Well, if we integrate f of x, we know those rules. Typically we would put a plus c. Because we now have bounds, the plus c's will not need to be there. If you look in our book, there's a quick explanation as to how the constants will actually cancel out. We use this bar. This means we're going to evaluate this antiderivative from A to B. And so you would find f of B minus f of A. Okay, so here's a very quick example. If I have the integral from 0 to 2 of, say, x plus 3 dx, I would integrate. So again, just with your rules that we've been learning, this would become x squared over 2 plus 3x. And we're going to evaluate that from 0 to 2. And therefore, so we do 2 squared. So we plug in, this is the part where we're plugging in our b into this function. So f of b is 2 squared divided by 2 plus 3 times 2 minus, I'm going to go down here, the quantity of now 0 plugged in. 0 squared over 2 plus 3 times 0. And what we get when we go through the computation here, this whole thing equals 0. So we have 4 divided by 2, which is 2 plus 6 equals 8 units. So what that means is the answer to this integral, this definite integral, is 8 units. That means the area under the curve from 0 to 2 for x plus 3 is equal to 8. Now we're looking at another definite integral. As we look at this, do we have rules in which we can integrate secant squared? Yes, the integral of secant squared is tangent x. And as a reminder, if you're still a little unclear on the rules, differentiate tangent to x and it should be secant squared x. And we're evaluating this from 0 to pi over 4. So when I work down to here, what I have is the tangent of pi over 4 minus the tangent of 0. The tangent to pi over 4 is 1. Root 2 over 2 divided by root 2 over 2 is 1. Minus the tangent at 0 is 0. The answer is 1. So again, the area under the curve for secant squared x dx from 0 to pi over 4 is equal to 1 unit. With integration, we also have a new formula. So once you know a definite integral, we can now apply what we call the average value of a function. So very simply, you find the definite integral and you multiply it by a constant of 1 over b minus a. So an example here, find the average value of f of x equals 3x squared minus 2x on the interval of 1 to 4. So what is the average value, or what is the average y value going to be as we change on this function on this interval? So we would simply go 1 over 4 minus 1, or 1/3, from 1 to 4 of 3x squared minus 2x dx. The integral would then be x cubed. We would add 1 to here and then divide by 3, and that will cancel out, minus x squared from 1 to 4. So we have our constant 1/3 times, now let's plug in our b and our minus our a. So we would have 4 cubed minus 4 squared minus 1 cubed minus 1 squared. And as you can see, that goes to 0. So we have 1/3. And we have 64 minus 16, which is 48, which equals 16. So the average value of f of x minus f of x equal to 3x squared minus 2x on the interval from 1 to 4 is 16. This topic of average value pertains to the problems on page 327, numbers 51 through 56. They say in the directions mean value theorem, well, that's the same thing as talking about an average value of a function. So please understand there's not much of a difference there whenever you're reading the directions.